So take you a drink of hard liquor because this is the example that we're getting ready to do. And this was the equation that we just learned. We use this equation to compare two methods. Okay, I'm going to say that again because it's important. This is used to compare two methods. We have one method that has its own average and standard deviation associated with it, and we have another method that has its own average and standard deviation associated with it. They're different methods, they process the samples a different way, they analyze the samples a different way, and it's our job to figure out, are they reporting the same answer or the same story? We know they're going to be different, but are they close enough? That's the question that we always ask. So in the example problem, which was here, it did quite a bit of the work for us already. It gave us the averages and the standard deviations for both. So the average and standard deviation calculations we didn't have to do. We just have to know where to put them in the actual calculation itself. All right, so with that said, I told you start with S pooled first. If you start with the S pooled first, then you're going to use that number in the major equation, and that's where we always need to start. It makes sense that way. So if I look at this S1 squared, this is my standard deviation for my first method. So if I go through and find it, method 1, my standard deviation was 0.00014. 0.0014 is what that was. So I'm going to erase this. And I'm going to put 0.00014 here. And that number has to be squared. So N1 is the number of measurements for that very first method that I'm referring to. And it says that we did that for 7 measurements. So 7 times is what we did there. All right, so a 7 is going to go in for that N1. So I'm going to delete this, and I'm going to write a 7 here. All right, so now we get this S2. This is the standard deviation for the second method. So I'm going to erase that. Well, what was that standard deviation? It says my second method, whatever that was 0.00138. So 0.00138. And then I get N2, which is the number of measurements for my second method. And the problem tells me that we did that 8 times. So in the equation, an 8 will go there. And then we have an N1 and an N2 down here as well. So that needs to be erased. N1 was a 7, and my N2 was an 8. So a 7 goes there, and an 8 goes there. Okay, so there's the S pooled part of the equation. So in the calculator, I want to take this baby steps at a time. I'm going to do 0.00014 times 0.00014. That's squaring, right? That gives me 0.000000196. Well, that number needs to be multiplied by 7 minus 1. Well, 7 minus 1 is 6. I can do that in my head. I don't need to do that on a calculator. So I multiply that by a 6, and there's the answer. So if I count the number of zeros here, how many do I have? 1, 2, 3, 4, 5, and 6. So I've got 6 zeros, 1176. All right, so let's just get rid of all that mess. So I squared that number, multiplied by a 6, and that changes over to 6 zeros. 1, 2, 3, 4, 5, 6, 1176. Just double check it. 1, 2, 3, 4, 5, 6, 1, 1, 7, 6. All right. Now I'll do the other half. That's a 0.00138. I need to square that number. You probably have a square root or a square sign on your calculator. Use it. So there it is. And then I need to multiply that number by 8 minus 1. Well, 8 minus 1 is 7. So multiply by 7. There's my answer. So this one has 4 zeros after the decimal and a 133 afterward. So 4 zeros, 133, right? Okay, so let me erase all of that mess because we've cleaned that up. So 4 zeros and then 133. Again, double check it. 4 zeros, 133. Then down at the bottom, 7 plus 8 minus 2. That gives me a total of 13. So again, let's erase that bottom piece. And that changes to a 13 down here at the bottom. We're going to clean up the top a little bit. We're going to take the top part, point 1, 2, 3, 4, 5, 6, 1, 1, 7, 6, plus point 1, 2, 3, 4, 1, 3, 3. And I hit enter. And here I get 4 zeros and a 134. All right, so 4 zeros and a 134. So let's erase all of this now because that's just what I did. I took those two numbers and added them together. Four zeros, 1, 2, 3, 4, and a 134 that happens afterward, right? 0.000134. Take that number, we're going to divide that by 13. That's my answer. Notice it's to the negative sixth. So that means there's 5 zeros out in front of this number and then a 103 that follows it. All right, so let's erase all of that mess because that's what I just did in the calculator. Again, we're taking baby steps. Maybe you're one of those people that already have the answer, and if so, that's great, but we're taking our time. So 1, 2, 3, 4, 5, and then that would be the 6th decimal move. So there's my negative 6, and this was a 103. So we'll do the 103. Still not really finished. I need to S-spool it, which means I need the square root of that number. So if you have the square root sign on your calculator, now's the time to use it. If you do not have the square root sign, the way that you do it is that you take this to the exponent of 1 divided by 2, 1/2, which is 0.5. And there's your answer, 0.00101. Now, you can keep more numbers if you want to. It doesn't really matter at this point. 0.001015 or 2, whatever you want to use, it doesn't really matter. 0.00101 is what I'll keep. I can write the 5 here really little if I want to. That way I can remember what was there. But there is my S-pooled number. So that means my S-pooled number is going to go here at the bottom, right? That's the spot for S-pooled. This was so much garbage up here that they didn't want to put it down here in the denominator. So they just wrote, whatever you get for S-pooled, put it there. So that's what we're going to do. We're going to put 0.00101 here. Now the other pieces, what are those? My X bar 1, that is the average from the first method. So I'll go back to the problem, and it says my average was 2.31011. 2.3011. So we'll erase that. .3011 31011. And then my x bar 2 is the average from the second method, and that's a 2.29947. My N1 is a 7, my N2 is an 8, and again my N1 is a 7 and my N2 is an 8. I go into the calculator, I begin to solve this up. 2.31011 minus 2.29947. I hit enter, and then I divide that by 0.00101, and that gives me 10.534. I'm going to come over here to the side and write that. Times, well, in the calculator, 7 times 8 is 56, divided by, well, what's 7 plus 8? Well, 7 plus 8, 15. And I need to take the square root of that answer, which is a 0.193. And then I need to take these two numbers and multiply them. So 10.534 multiplied by 1.932, and I get 20.35. Now, what does that number mean? That's my answer. Well, I've got to compare that to something. What do I compare it to? Well, I compare it to the student T. This is at 95% confidence level. There's 8 on one side, 7 on the other as far as measurements go. That's a total of 15 measurements, which would be 14 degrees of freedom. Notice 14 degrees of freedom's not here, but 15's there. But look how small these numbers are. 2.131 for 15. Right? This is 20.35. Nowhere even near 2's. I don't even need a full chart for that. I don't need to find 14 because I know 14 and 15 and 16, they're all going to be really close together. So because my T calculated is greater than the T table, this means that the two methods are not the same. They are telling me different stories, which means one of these methods is better than the other. One of the methods I cannot use because it's too far off from the accepted value. They are not telling me the same story, and I've got to figure out which one it is. But that is the example that we've got to go through to compare two methods with each other to see if they are telling me the same story or not. And in this case, because my final answer, which is what we call T calculated, is greater than the T table number, that means these are not the same story. So again, I didn't need the full table to determine that. My 10 is 2.228. My 20 is a 2.086. My 14 has to be somewhere in between there. Nowhere near a 20. I don't need to find a table for that. I know my 20 is much, much greater than the T table itself. So because of that, they are not the same. Those methods are different. So I would maybe watch this video again just to make sure you can follow through the math and to make sure that you understand the steps. But this very last step is the key. How is the calculated number compared to the table? If the calculated number is greater than the table, they are not the same. If the calculated number is less than the table, then they are the same. It doesn't matter which one you use. They are telling you the same story in that case. All right, so good luck with it. We might do another example.